21st year. We're going to change and shift gears a little bit here to a different author who is at the book fair and who is joining us. He is Greene, the author of The Elegant Universe, and his newest book is called The Fabric of the Cosmos. He joins us in the room, and we will start talking. There he is. Hi, Mr. Greene. How are you?
Hi.
First of all,
thanks. How are you?
First of all, let me ask you to explain the type of writing that you do.
My books are aimed at a general audience that has some hunger, some urge to know how the universe works, but hasn't gone to graduate school, so doesn't know mathematics at the graduate level or even the undergraduate level, but still wants to know what current cutting-edge science is telling us about the universe. So the books take away the math, take away the technical details, and communicate cutting-edge science using analogies and stories and metaphors that allow you to grasp at a visceral level what's going on.
Now, you are a physicist, correct?
Yes, I am.
And when did you decide to start writing for a general public?
Oh, I decided around 1996 or so, after I gave a couple of lectures to general audiences and found that there was this great energy and enthusiasm to know what was going on, but there wasn't that much to point people towards to read further. So I decided to give it a shot, and that gave rise to The Elegant Universe, my first book.
And your second book, The Fabric of the Cosmos, deals with time. Give us a little bit of background on what you're talking about. What are the questions that we are asking about time?
Well, the deep questions about time are, does time have a beginning? Will time have an end? Is time a real feature of the universe, or is it something that we impose on the universe to organize our experience and our perceptions? Does time have a direction? Is past really different from future? Can that distinction, if it exists, be found within the laws of physics? These are the kinds of questions about time that we have been struggling with for a very long time, and in my second book, The Fabric of the Cosmos, I try to give a sense of where we've gotten after thinking about these deep questions about time for 300 years. Where are we today?
And where are we today?
Well, we've made a lot of progress. If you go back and look at what Newton told us about time, he said time is what you think it is. Time elapses in equal intervals for everybody. That is, your watch ticks off the same rate as mine does, regardless of where we are or what we're doing. But then we learned from Einstein in 1905 that that is not how time behaves. We learned that if you and I are moving relative to each other, our watches tick off time at different rates. We learned that if I am near the edge of a black hole, my watch will tick off much more slowly than yours will. Time is in the eye of the beholder. Now, that was 100 years ago. Since then, we have learned a lot more about time when we thought about it, how it interfaces with a field called quantum physics, the physics of the very small. And today, I think we're poised on the revolution of a new way of thinking about time and space as well, in which we'll learn that they're not even fundamental. We'll learn that space and time are definitely part of physics as we formulate it, but that at rock bottom, they are not fundamental ideas. There's something deeper that they emerge from, and the real prize is going to go to whoever can figure out what the true underlying ingredients that give rise to space and time actually are. We're trying to find the atoms, if you will, of space and time themselves.
For a public policy network like ours, can you take that one step forward and try to mesh the kind of work that's being done in this area with public policy debate? Is there any intersection?
Well, there is, because all of the scientific work that we're involved with has to be funded. And, of course, there are limited funds. What do you spend your money on? So, for instance, we were building a machine in Texas called the Superconducting Super Collider in the early 1990s. And that was meant to be a huge atom smasher, a huge tunnel in which particles would slam together at high energies, recreating events unseen since the Big Bang. And that was a very expensive undertaking, and it was ultimately canceled because budgetary constraints wouldn't allow it to go forward. This was a big blow to science. So there you see that the intersection of the work that we're doing with public policy can have a great impact on the rate of progress.
Greene is our guest, and first call from him is from Waukegan, Illinois. Hello, Waukegan.
Yes, my call was for the other gentleman. I'm sorry.
Okay, we'll go on then. Thank you. San Diego, hello.
Hi. Thank you so much. I'm calling from San Diego, and I was just thinking in the matters of public policy, if you could interest the venture capital guys into some aspect of what you're doing, believe me, the money will show up. If you position it, they will come. In regard, and I'm sorry, also, if you could just put tasty morsels of your book on a website so the rest of us could benefit. I called earlier in regard to the earlier authors, the same thing. I have a website called sandiegojudges.com, which went on pretty much like Courtroom 302. But the website keeps everyone on the same page, so to speak, or at least makes the knowledge available. So would you consider putting some of your stuff on a website? Not the whole book, of course, just little morsels.
Mr. Greene.
Sure. In fact, there are websites that do have a lot of the current thinking on some of the questions that we've been discussing. There's www.superstringtheory.com. If you go there, you can find a whole lot of information along the lines of what we're discussing here. My book itself, you won't actually find on any website, and not that I have anything against that, it's just it takes a lot of effort to put it out there, and were someone willing to help me. I don't know how to actually put things on web pages, but I'd be more than happy to have tidbits of the cutting-edge ideas about space and time to be out there more available, absolutely.
Do you think that some of us who have a little hard time understanding your world will think it's interesting that you don't know much about web pages?
Well, you know, I'm a theorist, and so everything that I do is really calculations on a piece of paper. And I think the younger theorists, who are, in fact, some of them are my students and postdocs, they certainly do know how to put things on web pages, and that's part of the reason why I don't, because I always give it over to them to do it. That's a danger of being an older person in the field, so to speak.
At the advanced age of?
You're asking my age?
Yes.
Oh, you know, somewhere in the 40s.
Let's go next to San Diego's not there. Let's go to Eastchester, New York, is that right?
Yes.
Go ahead.
Hi, Professor Greene. I just have a quick scenario for you. If you consider a reflective cavity encasing a charged particle that's oscillating with simple harmonic motion, and you consider that that oscillating charge will be radiating electromagnetic waves, and if you consider that those electromagnetic waves will uniformly distribute themselves throughout the cavity and induce impulses back on the charged particle, and eventually the system would reach a sort of classical type of ground state. What do you think about the possibility of deriving some of the fundamental aspects of quantum mechanics from this sort or any sort of general quantum mechanical hidden variable approach? Thanks.
Wow, could you translate that for us first, Professor?
Well, actually, I was gonna ask the questioner if he could repeat the question for me. No, that's okay. The questioner seems to have mixed a few ideas together, and I won't belabor some of the things that I'm having difficulty understanding and why they're being mixed. But the bottom line question was, can we think about quantum mechanics from a so-called hidden variable point of view? And this is an idea that was very interesting to Einstein himself in the 1920s and 1930s. He, in fact, wrote one of the early papers on quantum physics in 1905, but then didn't really like where the field went in the years that followed and was trying to find alternative ways of thinking about the physics of very small things. That's what quantum mechanics is. And as of today, all of those alternatives don't seem to match the data the way the conventional approach does. So the bottom line answer to the question would be, we still are adhering to the conventional description of quantum physics. Who knows where things will go in the future, but that's where we are as of today.
The earlier caller had brought up whether there might be some venture capitalists out there who might be able to fund the work. Does that happen? Private work in this area, or private financing?
Well, private money is very important to us, although much of our funding does come from the government. The government funding, though, is precarious at times. So many of us are seeking private money that would give us endowments that we could rely upon without any possibility of the money going away. The hard thing about attracting private money is we're not producing a product. We're not producing something that can be marketed. And that, of course, is usually important to venture capitalists. The private funds that we seek are usually more philanthropic money, people who want to support very basic research that in years to come may have a profound impact on the way we live our lives, but as of today is really in the very research stage. We're not really developing anything that can be put out there in the market.
You caused quite a scene with your earlier book, The Elegant Universe. You were nominated for a Pulitzer, was that correct? No.
That's correct. I was a finalist for a Pulitzer Prize.
Finalist for a Pulitzer. And I guess what I'm saying is, just in terms of the string theory, that something like the string theory became a part of the lexicon of people who may not have ever been involved or thought a whole lot about science. Where are we at with the string theory now?
Well, string theory is what we hope to be the unified theory that Albert Einstein was looking for the last 30 years of his life. And it purports to describe all the forces of nature and all of matter in one framework. And that's a very big goal. And we've been working on it for 30 years. Tremendous progress, wonderful and exciting ideas have emerged from those studies. But we have a ways to go. And the most important thing that we've yet to achieve is experimental evidence that these ideas are correct. Our hope is that in the next few years, a machine that's not being built on American soil, but in Geneva, Switzerland, a machine that's called the Large Hadron Collider, that machine at least has the chance of testing some of the ideas of string theory. It's not a certainty that it will, it's a long shot, but at least it's possible that in the near future, we may get some experimental input telling us that these ideas are on the right track. That is what we all are crossing our fingers about, and that's the most exciting thing on the horizon today.
And for a lay audience, what could be the impact of proving the string theory?
Not much from the point of view of everyday life, but if you were to have asked me in the 1920s, what would be the impact of quantum physics? I think if I was an honest scientist at that time, I would have told you, not much. You know, we're dealing with molecules and atoms. They're so small, so far removed from everyday life that quantum physics won't really have an impact. But today, 80 years later, your cell phone, your personal computer, all manner of medical equipment and technology, everything that relies upon an integrated circuit, and they are everywhere in our culture and our society, all of that relies upon quantum mechanics, which is just to say that you can't really know where basic research is going to lead. So you ask me today, where will string theory take us if it's proven right from that point of view? I don't know, but 500 years from now, 1,000 years from now, if string theory is correct, it could have a major impact on the way we lead our lives. For someone like me, though, that's really not the goal. Our goal is to understand the deep questions, how the universe began, the questions about time that we started off with. Does time have a beginning? What is time? Those are the kinds of questions that we may be able to answer if string theory is correct. That's what's motivating me and a whole generation of scientists around the globe.
Next call for Brian Greene is Newark, California.
Hi. It's going to be obvious that I don't know anything about physics, but I am curious. What preceded the Big Bang? You know, and if the Big Bang was a beginning, to me that implies that there had to be something before it, and what was that? And is our universe endless? Are we contained within something larger, or is there something beyond what we conceive of as the universe?
Mr. Greene.
Yeah, those are two great questions. Was there something before the Big Bang? And the quick answer is we don't know. But let me just flesh it out a little bit. It could be that the Big Bang was the very beginning of time, that there was no notion of time before the Big Bang, and therefore talking about the word before doesn't even make any sense. It's as if you're walking on the surface of the earth and you ask somebody which way is north, and they point you north. You ask somebody else a little while later which way is north, they point you north again. When you get to the North Pole and you say, how do I go further north? They look at you kind of strange and say, you can't go further north. The North Pole is where north begins. It could similarly be that you can imagine looking back in time, looking further back in time, but when you get to the Big Bang itself, you may not be able to go further back in time in much the same way as you can't go further north than the North Pole. So the Big Bang might be where time itself began. Now, from the point of view of science, today we don't know that that's correct. We are struggling to figure out, maybe there is a realm before the Big Bang where there is time or some other notion that evolves into time at the onset of the Big Bang itself. Great questions, we're still struggling. But in terms of, is there something beyond the universe that we currently see? Again, we don't know, but current theories of cosmology, a theory known as inflationary cosmology, strongly suggests that what we see is a tiny little part of a much grander cosmos. What we have access to is like a single grain of sand on a huge beach filled with other grains of sand, which in the metaphor would be other universes, other regions of space that are beyond our ability to see today. So it's very possible that what we have long thought to be the universe, the 14 billion years of evolution that we have access to with our telescopes, that may be a tiny fraction of a much grander cosmos.
Toledo, Ohio, you're next. Go ahead.
Yeah, hi, thanks a lot. Quick comment. Thank God for C-SPAN. I mean, it's the only channel worth watching for news and current affairs, like Mr. Greene here. I mean, dear God, I mean, can't even see a man like that on CNN, for crying out loud. Well, I guess the previous caller asked my questions for me. I mean, essentially my question was, you know, is there any limit to the universe? Are there any boundaries? I mean, where exactly are we floating? And just a quick other question. What was so great about Einstein? I mean, even now, today, every, scientist or whatever I hear always refers back to Einstein. What exactly made him so great? Thanks a lot.
Sure. Well, it's very natural when you think about the universe to imagine that it has edges, because every object that we look at always has some finite extent and some boundary to it. Could it be the case with the universe? We don't think so. If the universe had an edge, you'd imagine going up to the edge and punching through. What would be on the other side? Not the universe, some other kind of universe. So most of us believe that the universe doesn't have boundaries or edges. Either it goes on forever, or like the surface of the Earth, it kind of curves back, so that if you went walking in one direction, you wouldn't hit an edge, you'd rather ultimately return to your starting point. Now, in terms of what made Einstein so special, I wish I knew, because I would take some of whatever he was taking, because he was able to see so much further than anybody else. And if you posit a guess as to why, it's because he had this childlike questioning character that we see in 3-, 4-, 5-year-olds, but he didn't lose it as he grew older. He was willing to ask those seemingly simple-minded questions, take them very seriously, and he had the intellectual capacity to see beyond where anybody had previously seen and come to new ways of thinking about the universe. So roughly speaking, that is how he lived. He was a questioning man, and he would not give up on a question until he found the answer. A single-mindedness in the mind of a genius is something very, very powerful.
Do you have another book on the way?
I'm thinking about it, but nothing that I'm writing right now.
Well, if, for our viewers, if we've whetted your appetite, this is Brian Greene's latest book. It's called The Fabric of the Cosmos, Space, Time, and the Texture of Reality. Mr. Greene's previous book was called The Elegant Universe. Brian Greene, thanks for joining us today.
Thank you.
And that concludes our live programming from the Chicago Tribune Printers Row Book Fair for today. We will be back tomorrow. We will be beginning at 12:30 Eastern Time. That's 11:30 Central Time. And you will see such people as Richard Parker talking about John Kenneth Galbraith, Ted Fishman talking about China, people talking about oral histories of Chicago immigrants. Janet Conan has a biography of Robert Oppenheimer, and Michael Lynn will be talking about what Lincoln believed of the value of convictions of America's greatest president. We'll also be taking phone calls for a lot of our authors, so we invite you to join us then. Thanks for joining us. You've been watching Book TV's live coverage of the Chicago Tribune Printers Row Book Fair.